So hello and welcome everyone. It is lovely to see you all. We have something like 230 people registered for today's event. So we're incredibly grateful for the time you've given us and to join us for today. Today's presentation is on Industry 4.0. So what you need to do next. This is a second webinar in a series of dedicated sessions aimed at partnering with academic colleagues across the institution to showcase the work that they're doing that is important for you. So current issues that they are currently researching that is important for you, our community. We have with us staff, we have students, we have alumni, we have our industry engagement activities and all of our industry partners. It is lovely to have you all here. I'm really honoured and blessed to be emceeing for this afternoon. My name is Chris Eunice. I'm the Executive Director of the Office of People and Success. On behalf of the university and of the team, welcome, and it's lovely to have you all. We've got numbers climbing as people are coming into today's session, so great to have you all here. As is accustomed to Western Sydney University, we normally like to start our meetings with an acknowledgement of country. So with respect for Aboriginal cultural protocol and out of the recognition that our campuses occupy their lands, Western Sydney University acknowledges the Darug, the Tharawal, the Gandagara, the Wiradjuri peoples and thank them for their support of the work we do in their lands. We are constantly reminded that we live, work, learn and play in lands that are owned by our Aboriginal friends, family and colleagues. And I'd like to extend my welcome to any Aboriginal and Torres Strait Islander people we have with us here today. I'm pleased to introduce our speakers. We have Dr. Rama and Dr. Prem from our School of Business here at Western Sydney University. Dr. Rama is currently an adjunct professor from the School of Business. His postgraduate teaching, his research, international consulting focus is on the transfer and application of Industry 4.0 technologies and operations and supply chain management for enhancing competitiveness and promoting a circular economy. In his career spanning 48 years, Rama has worked as a mechanical engineer, a management consultant, an academic, and a director of the United Nations Agency. Welcome, Dr. Rama. We also have Dr. Prem. Dr. Prem is a senior lecturer here with the School of Business and teaches and coordinates units in logistics and supply chain management. He has many educational and professional qualifications, including a PhD in manufacturing and industrial engineering from the University of Melbourne and a master's engineering in industrial engineering and management. He has also completed a SAP certification on best practices in enterprise resource planning and is a certified solution consultant of SAP ERP for small and mid-sized enterprises. Welcome, gentlemen. We are over to you for your presentation this afternoon. Thank you.
Thank you, Chris, for the kind introduction. Before I continue, I would like to thank the Western alumni team of the Office of People and Success of the Western Sydney University for giving my colleague Dr. Prem and me the opportunity to share the findings of some of our work that we have been carrying out at the School of Business in the area of Industry 4.0 under the leadership of Dr. Prem. Over the last 5 years, the term Industry 4 has become a global buzzword in the world of business. It is talked about extensively as the fourth industrial revolution that can have a profound impact on both local and global manufacturing value chains, not just in industrially advanced nations like Australia, but also in less industrialized low-cost nations, which are more popularly referred to as emerging economies. Now, why do we refer to Industry 4.0 as the fourth industrial revolution? As all of you are aware, over the past 250 years or so, there have been 3 earlier industrial revolutions involving disruptive technologies. The first industrial revolution came about in Europe thanks to the power provided by the steam engine, mechanization, and the weaving loom. And it is well established that it was the first industrial revolution that led to the enhancement of the economic and political power of the United Kingdom and many other nations in Europe. The second industrial revolution came later due to the availability of a reliable supply of electrical power, which then led to large-scale production based on the assembly line. And again, there is empirical evidence to suggest that the rise of the United States as a global economic and political power was due to the second industrial revolution. The third industrial revolution, which came about during the latter one-third of the 20th century, was due to automation and the coming together of computing and telecommunication. In fact, now we use the term ICT, information and communication technology, rather than information technology. One might say that the fourth industrial revolution that we are now going to talk about has built up on the gains of the first three revolutions and has actually made a quantum leap by creating what is now popularly referred to as cyber-physical production systems. But more about cyber-physical production systems in a short while. However, what is important to remember is that these three industrial revolutions did not involve only disruptive technologies, but also incorporated many managerial innovations that helped companies to get the best out of the disruptive technologies. Essentially, the combination of these disruptive technologies and the managerial innovations revolutionized the way production processes were organized, goods were produced, the flow of materials, information, and finances along the supply chain, and how they flowed. And all this made a truly big impact in manufacturing. The importance of Industry 4.0 has been discussed quite extensively and has been emphasized by heads of government, by CEOs, industry leaders, and by management consultants from prestigious consulting companies across the world. So now let's ask ourselves, we talked about disruptive technologies accompanying each industrial revolution. So what are the disruptive technologies that are behind Industry 4.0? These disruptive technologies are referred to as foundational technologies or sometimes as exponential technologies. And these include, among others, the industrial Internet of Things, cybersecurity, the cloud, additive manufacturing, or 3D printing as it is popularly called, augmented reality, big data and analytics, autonomous robots, simulation, and horizontal and vertical integration. In fact, Industry 4.0 is essentially a very clever combination of these foundational or exponential technologies, as they are called. And this very clever combination has led to the development of what we call cyber-physical production systems. These cyber-physical production systems have enabled us to do several things. Firstly, it has promoted vertical networking of production systems within a company. So when we have production systems within a company network together and are able to function with minimal human intervention, we refer to these as smart production systems. So essentially what these foundational technologies have done is enabled us to create cyber-physical production systems which have promoted vertical networking. The next important contribution that these cyber-physical production systems have made is the horizontal integration of global value chains. In other words, if you take a supply chain, the cyber-physical production system in one entity of the supply chain can now communicate with the cyber-physical production system of another entity in the supply chain, and once again, with minimal human intervention. In other words, we are building in a tremendous amount of intelligence into the machines thanks to all these foundational technologies. The third significant contribution that the cyber physical production systems have enabled us to do is to promote collaboration along the entire supply chain. And this is now possible in real time. And this kind of collaboration along the supply chain enables a supply chain to deliver to their customers what they want very quickly, and has even enabled the introduction of new products and services very quickly when compared to previous generations. And this is referred to as through engineering collaboration along the entire supply chain. So given the tremendous potential that Industry 4 can unleash, why is there still some hesitation? One of the reasons why there is some hesitation is because practitioners have expressed several concerns. One of the biggest concerns that has been expressed by practitioners is that a large amount of investment would probably be needed to upgrade machines, the information technology infrastructure, ensure that the new processes are on par with the cyber physical production systems, so re-engineering business processes, and then hiring the expertise that can get the best out of these cyber physical production systems. So that's a concern. How do we find the investment, and how do we spread it out, and how do we do it in phases? The second issue is related to cybersecurity and intellectual property theft, because when all the entities in a supply chain are linked together with minimal human intervention, how do we ensure that intellectual property is protected? How do we ensure that sensitive data remains safe? Concern has also been expressed about the skill profile that we need to develop in our staff so that they can get the best out of the cyber physical production systems in an Industry 4 setting. And needless to say, there is the fear that some traditional industries may not survive in an Industry 4 setting. Happily, there is plenty of evidence to suggest that these concerns are being addressed very effectively, and very soon these concerns are likely to become less. So if that is the case, and if the manufacturing sector transitions to an Industry 4 setting, what are the advantages that one can expect to come about due to this transition? There are many, and I just cite a few here. Improved product design and improved interaction with our consumers. As we just mentioned a short while ago, the through engineering collaboration along the entire supply chain will make it possible for companies to work very closely with consumers so that consumers can now actually become prosumers, meaning proactive consumers. So this is a terrific advantage that companies can have so that they can respond very quickly to changing customer needs. Secondly, the assembly process is likely to become much simpler thanks to machine-to-machine interaction and less human intervention, and this would result in considerable amount of reduction in waste, thereby contributing to a circular economy. Thirdly, we can also locate manufacturing facilities now closer to the consumer, and this can facilitate agile production, meaning we are able to respond very quickly to changing customer needs. It can rationalize warehousing, and we can also reduce the carbon footprint of the supply chain. Fourthly, the use of these foundational technologies and the intelligence that can be built into the cyber physical production system will now lead to component consolidation, and the use of technologies such as 3D printing can reduce the number of stock keeping units that a firm needs, thereby resulting in lower investments in inventory. The holding costs start coming down dramatically. So given that the concerns are being addressed and that there are benefits to be gained, what can we say about the adoption of Industry 4 technologies by manufacturing firms across the world. A recent survey conducted by the Boston Consulting Group and the World Economic Forum has come out with some rather startling findings. While the study has shown that there is very good understanding of what Industry 4 is, what the advantages are, and what it can do, the survey showed that less than 50% of the companies surveyed have talked about actually implementing a cyber-physical production system in their companies, and only a very few have actually started piloting it. Now, this is a cause for concern, and what we find is that this is best reflected by Ulrich Grillo, who is the president of the Federation of German Industries, who observes rather wryly that the only success of Industry 4 is that it's on everyone's lips. So now the issue that comes up is, why is this happening? And can companies be content to remain under the third industrial revolution and keep postponing their transition to an Industry 4 setting? Now, my personal view, based on, of course, a lot of the evidence that we have come across during our research, is that transitioning to an Industry 4 setting is no longer an option. It is an imperative. And the reason is simply this. We are now moving into what I would like to call new globalization. So the moment I use the term new globalization, one would ask, so is there something called an old globalization? And yes, and I would like to just say a few words about the old globalization before I move on. We all know that during the latter one-third of the 20th century, many staggering political changes took place globally. And these staggering political changes resulted in what we now refer to as globalization of business. And thanks to globalization of business, what happened was continental economies like China and India opened their borders to international trade. And this was very quickly followed by many other nations across the world. And increasing international trade brought about great benefits. So that's the old globalization that was there during the latter part of the 20th century and well into the 21st century. But I believe that now we are entering a new phase. And as I mentioned, I would like to call this the new globalization. A new globalization is now coming about thanks to Industry 4.0. In the old globalization, we had what is called concentrated production, where production was concentrated in big factories located in low-cost countries like China, and large quantities were produced and shipped out of these locations all over the world. But Industry 4 technologies and the cyber-physical production systems have now flattened the cost curve. And there is now the possibility of setting up small local factories which can produce at a competitive cost and which can quickly meet local demand. Now, I'll talk about an example in a short while in my next slide. So this is one of the biggest changes that Industry 4.0 is bringing about: distributed production. In the old globalization, we had cross-border trade. We had multilateral agreements, market liberalization, and the emphasis was on lowering the cost of cross-border trade. But now, what we are seeing is that governments across the world, especially in the richer countries, the technologically advanced and industrialized countries, governments are beginning to encourage their companies to bring back manufacturing from locations to which they had previously offshored. And this was seen dramatically during the presidency of Donald Trump in the United States. And this is true all over the world. And the pandemic, the COVID pandemic, has also brought about the realization that relying exclusively on outsourcing and offshoring would be disadvantageous. And Industry 4 now provides the opportunity to have local supply. And companies are now beginning to take this very seriously, because bringing back manufacturing to their home countries is going to meet with approval from the government, because you are now creating more jobs, local jobs, and furthermore, using Industry 4.0 creates lots of other opportunities in the periphery. In the old globalization, what we found was that companies gathered data about customer preferences and customer demand, and they spent quite a lot of money on this, and they used this information mainly to improve forecasting and to improve supply chain performance. But now, when we have all the companies networked along the supply chain using Industry 4 technologies, information flows very quickly. And rather than spending a lot of time collecting all this information, it is now possible to gather this information quickly and engage in real-time demand planning, improving new product development approaches, and providing greater customer service. So again, we are moving from global customer access to local access. And in the old globalization, cross-border collaboration was mainly through the internet, and the internet connectivity enabled the integration of global supply chains and supplier networks. Now, under the Industry 4 setting, this kind of cross-border collaboration is not limited, but becomes more extensive, because it does not mean that with Industry 4.0, we have to completely get rid of offshoring and outsourcing, but we can use a very clever combination of local production with a bit of offshoring and outsourcing and create what are now referred to as cross-border ecosystems. So the trend is now moving to new globalization. And if companies stick to old globalization modes of operation, the chances are they are going to miss out on a lot of the opportunities that new globalization offers. I would like to take this example of the shoe factory of Salomon, Millet, and Babolat in France. And I would like to quote the Vice President Footwear category at Salomon, Guillaume Mezenc, and I quote what he has said. About 10 years ago, it became apparent that the way we have been producing in Asia up to now would no longer be the unique solution, where we have massive factories and thousands of workers, and that we have to build our own production in France. He goes on to point out that new product material developments, new production methods, digital design technologies, together with ongoing digitalization and automation, have created completely new possibilities. In fact, what he is doing is he's talking about Industry 4.0 without using those words. And what they have now done is, in France, they have set up an advanced shoe factory 4.0, which is a grim reminder that they are using Industry 4.0. And what we see here is a unique factory, fully automated, digitally controlled production with robots, which is another term for cyber-physical production systems. And instead of 500 people, there will be 50 people. So even if your labor cost is 10 times higher than the labor cost in China, you can still produce at a comparative cost. That's the message that Guillaume is conveying. And he's saying that if you can use these technologies, the goal is to become much faster and to change product lines more quickly. Now, this is a reminder, and I use the word grim reminder, and I use that word deliberately because emerging economies, which are now relying very heavily on offshoring and outsourcing, are going to be terribly concerned because now production can move back to the countries from where they were originally outsourced or offshored. And today we see the term reshoring being used rather freely among practitioners and strategists. So this confirms that transitioning to an Industry 4 setting is not an option, it's an imperative. Now, having made the argument that it would be advantageous for companies to transition to an Industry 4 setting, the question naturally arises, why is there so much inertia in making this transition? What is it that is pulling the companies behind? And as reflected by the Boston Consulting Group survey that I just discussed a short while ago. And the reason is simply this. That survey led to the conclusion that one of the biggest problems is that many companies tend to treat Industry 4.0 as a technological opportunity rather than a strategic initiatives. In other words, they still have that old globalization mindset where you throw an old machine and buy a newer, superior machine. So that is the technology opportunity mindset. Let's look for a better machine. So Industry 4, while it has many foundational technologies and it offers those kinds of opportunities as well, it must not be seen as just replacing old technology with new. It must be seen as a strategic initiative that calls for a new way of thinking and a new way of doing things. And unless they do that, companies will not be able to obtain sustained business value. Having said that, before I pass on to my colleague, Dr. Prem, what is important to remember is that companies that wish to embrace Industry 4.0 and transition to an Industry 4.0 setting must realize that significant benefits are gained only when organizations re-engineer their manufacturing processes holistically based on the right mix or a clever mix of technology, data, skills, and managerial interventions. And this is where we see the Boston Consulting Group has coined the term bionic companies. Bionic companies are those that combine human and technology capabilities. And a recent study that they have carried out shows that companies that have transitioned to a bionic setting are now generating about double the earnings and enterprise value of other companies that are still stuck in the old globalization mindset. So the question then arises, how do we start our transformation journey to a bionic setting? And the first step in doing that would be to assess how ready your company is to transition to an Industry 4 setting. And this is where I will stop, and my colleague, Dr. Prem, will take over.
Good afternoon, everyone. Thank you for joining this webinar, Dr. Rama. Thank you, and thank you, Chris, for very kind introduction. Now, as Dr. Rama said, yes, the question arises, how do they go into the transition of Industry 4 now? As you can see, we have developed this framework for assessing the Industry 4 readiness of a manufacturing firm. Now, this is based on a comprehensive analysis or review of several models, concept, technologies associated with Industry 4. And this framework also can be used as a guide for many manufacturing firms to start their assessing the readiness level. Now, when you see on the right hand side, this framework is shown in a schematic view with 8 determinants. These 8 determinants are closely related to many different aspects of the organization, including the technological, product, process, and people aspects. The first thing that many organizations could have in this transition to Industry 4 journey to answer these 3 questions: where are we standing, and where we should go, where should start. This framework can be used as a guide to answering those 3 questions. Now, the framework has got these determinants based on all of these areas and got number of elements. Next slide, Dr. Rama. Next slide. Dr. Rama, next slide, please. Yes, as mentioned, this schematic or the framework has got 8 determinants. They are closely related and associated with the organizational, technological, product, process, and those are the people aspects. Now you can see each and every determinant have got number of elements. So, for example, the strategy and organization have got 6 elements that we are not showing here, but yes, plant and equipment has got 4 elements, and each one of these elements all together, this framework has got 33 elements. Now, each element is described by a technological concept and managerial innovations. As Dr. Rama mentioned, this is not just only the technology but also the managerial innovations. Now, each element is measured by the level 0, that is the lowest level of Industry 4 readiness, to the level 4, that is the highest level, meaning that's the best practices of Industry 4. Now, if you can go to the next slide, Dr. Rama, I will explain one of the determinant. Now you can see the one of the determinants in this framework is plant and equipment. And as I mentioned, in this determinant there are 4 elements. On the left hand side, they are called the criteria. Now under the criteria, the 4th one is very much the common thing that we all know, the maintenance of plant and equipment. Now you can see at level 0, the company could be operating at only breakdown maintenance, whereas at level 4, the company could be operating at total productive maintenance. Very importantly, the emphasis here is by using fully implemented and controlled by a cyber physical system. Not just that, but also they could be using, or the organization could be using, the sensor technologies and big data analytics to do this. So you can see each and every element, in this case only one particular determinant and only one element of that determinant I am talking about is moving from level 0 to level 4. And if any organization is evaluating their readiness and looking into this particular determinant, they will be simply looking at where they are operating under this determinant, under this criteria. So that's very much they are looking at the level of their operation or the plant and equipment as part of the overall assessment. As I mentioned, there are 33 elements under this particular assessment framework. Now, if you can go to the next slide, Rama. Now, what we do have with this framework, we do have this framework available in the public domain. As you can see, this methodology was developed during a project undertaken by the Japanese think tank that we both involved, and it was published earlier and also available under this link. I hope that you get access to this through the access of these slides by requesting, and also if you look at the the methodology very much is in the public domain. Now, the interesting part of this framework is the determinants which are not just independent but also interdependent. And what we are looking at, yes, we can look at this framework as a self-diagnostic tool, and it's a user-friendly self-assessment, and also we have developed this as part of our research. Now, also we have tested this framework. For example, the methodology was tested in 3 large organizations in ASEAN region. First was at the Isuzu Bangkok, and also the second one at an integrated textile manufacturing plant in Indonesia. So the counterparts from these 2 countries who were involved in this area project did the assessment using the framework that we had developed. And both organizations found the assessment findings insightful in terms of looking at each determinant at what level they are in their industry for readiness. The third instance of testing the methodology was at a large glass container manufacturing plant in ASEAN region. So both of us participated as facilitators when a senior management team from this glass manufacturing company did the assessment. So in the third testing or the third case study, we involved both of us. We did not, this is the important thing, we did not do the assessment, but only provided clarification to questions raised by the senior management team while they were doing the assessment. By watching the team carried out the assessment, we were very convinced that the readiness assessment was not difficult to carry out. So very much we did not do the assessment, but we just clarified the questions that they had. After carrying out the assessment, the senior management team used the findings to develop a paced approach to transition to an industry 4 setting. As Dr. Rama mentioned, any organization that they look at their readiness will have to set guidelines for a paced approach. This particular organization did exactly that. Based on their assessment, they went for a paced approach. In fact, the first project under their Industry 4 implementation is called digitalization, very much linked to their ICT systems. Based on the experience gained from the exercise, we felt that we should work on an approach that will make it easy for management team from a manufacturing firm to carry out the readiness assessment. We emphasize this. We do not do the readiness assessment. Now, as a continuation of this project, we have already developed this self-diagnostic tool on an online platform, that is the Qualtrics, and we are also planning to run a training session to demonstrate how the industry can use it. And we are also extending our research to look at not just the level of the readiness of each and every determinant, but also to find the priorities of different determinants and the interdependencies depending on the organization and the industry. For example, the case study that we did in ASEAN region of that glass manufacturing, they did not only find the insights of their assessment, but also they found the interdependencies that help them to set an industry 4 transition by choosing a combination of lowest level rank determinants as the first project. Now, what we are also planning to publish this work. In fact, the first thing findings will be shared at the school seminar and also presented in journal publications. Thank you all. And Rama, do you have anything to add?
No, Prem. Thank you very much. That was a very nice explanation on the assessment. Thank you.
Thank you, gentlemen. I really appreciate having you all. We still have quite a few participants with us, and but we are over time. So I do want to just give you a minute to answer some of the questions that have come through from our guests. So Kim has asked a question about many are still Industry 2.0. Do you suggest that Industry 5.0 might be adopted before implementation of Industry 4.0? So 1 minute, who wants to answer that one?
it is true that there are in many countries, in almost all countries in the world, there will still be companies at the industry 2 and industry 3 levels. So by no means are we implying that all companies should transition to an industry 4 setting. The companies that should transition to an industry 4 setting are those that wish to compete globally and also to protect yourself from global competition. So it is, there will be several companies which are currently in industry 3 mode, transitioning to industry 3.4, transitioning to industry 4.0. So it is not that all companies should move to an industry 4 setting. Secondly, I just want to add that it is not just a question of going ahead and buying a smartphone and not just relying only on the traditional landline. So it's not that kind of leapfrogging. To be able to move to the higher levels, you need to develop the necessary managerial capabilities, the production networks, your supply networks, your customer networks. And so as we go from industry 3 to industry 4, it is important to build up all these relational capital, these intellectual capital as well. So the companies that are in industry 4.0 may well transition to an industry 5 setting more easily than a company that is at industry 3.0 trying to leapfrog to industry 5.0. So that's a very quick couple of quick comments.
That's a good minute. I appreciate it, Dr. Rama. We have some other questions. One here from Z. I like this one. It says, this is great for companies who want to decrease production costs via automation, resulting in, for instance, employee reduction from 500 to 50. But as employees are replaced by robots, won't there be little jobs available? And who's going to buy the products being made faster and on demand via 3D printing, for instance? Also, there seems a political impact as well. So, for example, where lines of national sovereignty become blurred. Do you guys have 1 minute response on this important question?
Yes, this argument has been there with industry 1, with in the industrial revolution 1, 2, 3, and now it will definitely be there again. When industry 3.0 and automation came in, the same arguments were raised about loss of jobs. But actually the number of jobs that were created increased, they were much, much more than what was lost due to automation. The other issue is that if you do not transition to industry 4.0, another company that has embraced it will flood the market with their products, which people will buy, and your 500 people will lose their jobs. So it is a question of managing the transition when there will be some amount of job replacement, but eventually the number of jobs will increase due to a lot of peripheral opportunities that are created. And this is not my view. This is the evidence in industry 1, 2, and 3.
Of course. Thanks, Dr. Rama. Dr. Prem, did you have something you wanted to add?
Okay, now if I want to add something, what Dr. Rama said is definitely that when there is a shift of automation to very much advanced technologies, yes, there are not people doing things manual, but people can be deployed in a better, and again, peripheral jobs like, in the automotive industry, if you look at the manufacturing of the automotive is not just that, and it has got so many parts that are being manufactured in local context. So you are talking about, if you want to have that local supply, that's the concept of industry 4, where you do get not just the automotive industry, but also get the manufacturing of the parts as a local supply. So you are talking about having the employees redeployed, not just within the organization, but also part of the complete supply chain. The most important part is as a local supply. So that's, we are talking about, not, of course, may not be in the same organization, but this is within the local context that the people will be employed. Again, as Dr. Rama said, yes, when automation came, people thought, yes, there could be a lot of job losses, but it wasn't the case, because you can be very much productive in other areas.
Yeah, great. And I think this leads to the next question, which I know Dr. Rama is going to answer in chat, which is that Industry 4.0 requires good innovation management frameworks. And I think you're speaking to some of that here in relation to the development of new innovations and supply chain. So, yeah, Jens, did you want to add any more to that, that particular question?
That is absolutely right, what you just said, Chris. Innovation management is absolutely necessary. Without that, without good innovation management, it wouldn't be possible to combine these foundational technologies creatively. So that's very important. You got to think very cleverly and innovatively as how to get the best out of it.
Absolutely. Great. The next, oh, sorry, Dr. Prem.
Yeah, I also can add to what Dr. Rama said. Of course, if you look at, if someone wants to see the framework that we have developed, and also the basis that we have developed, that we are not just talking the technology, we are talking technology, concept, and managerial innovations. And in the transition, people can see that managerial innovations can be very much, the people can be involved in, not the hard and fast technology as such. It could be managerial innovation that people can be very much like the example that we did in Bangkok, glass manufacturing. They were talking about having the plant maintenance with the best practices of Industry 4 using cyber physical systems supported by sensor technologies and the big data analytics using the SAP cloud solution as part of their ERP solution. So they were looking at how they can do the ERP revamp, because they have been paying a lot for the solutions that they have not used to the maximum potential.
Yep. Yeah, great. So I've got one more question. I think we've answered one of the, well, two more questions now. We've answered one of the questions that are here, which is what are some of the strategies to combat the concern of human resources losses? And both of you gentlemen have explained that in the supply chain, there are many jobs available, and creating local jobs and local production opportunities and expanding one's thoughts about where jobs are support that. So we won't go over that again, but there is a great question here, which is very important to us at the moment, especially in the Zoom environment, which is there a shift to a new paradigm because of COVID-19? Has Industry 4.0 accelerated, changed because of where we are now because of COVID-19? 1 minute. Who would like to respond?
I think companies that were reluctant to transition to an Industry 4.0 setting are now realizing that it would be good to do that, because in future, if there is again another big disruption of the global supply chain, then what do we do? So I think this new paradigm of Industry 4.0 is going to be looked at more seriously thanks to this pandemic.
Yeah, agreed. Another question here is, if Industry 4.0 is not part of the current strategies in place, what do you think are the #1 concerns? And I think you've mentioned, Dr. Ramos, about globalization. If you want to compete globally, you need to consider Industry 4.0. Is there any other concerns if we don't implement 4.0 as part of our requirements?
See, the biggest concern that a lot of companies have is they think that to transition to an Industry 4.0 setting, you got to go all the way and invest very heavily. But what is important to remember is you can do it in phases.
Yep.
And when you implement it in a modest way at the beginning, then Dr. Prem gave a good example of this large glass company. What is going to happen is you're going to get a lot of savings. And those savings can then be plowed back to move again another step. So it is not as if you got to go to the bank and borrow millions and millions of dollars to transition to an Industry 4 setting. You can use some money from your general reserves or even borrow modestly and make the first step. Use the savings then to consolidate and move further. So I think one of the reasons why they don't include it in current strategies is because of this concern of investment.
Yeah.
But I think that can be managed.
Yeah, agreed. That's a good point. You don't have to spend millions and millions of dollars. That's a great point. I think we're coming to probably our last few questions. So the last one I'll take, and then I might call to an end. We still have a few participants with us. So in the new globalization, focuses on local production for local supply. Will Industry 4.0 be expensive for the end market with new technology solutions? Is your thoughts that Industry 4.0 will be expensive for the end market?
Well, the evidence suggests, or whatever evidence we have now, suggests that this is not going to be the case. In fact, the example that I gave, the French example, they're actually able to meet the demand locally without a substantial increase in costs or prices.
Yeah, agreed. All right, well, thank you very much for tuning in, everybody. For those that are registered and those that have seen the presentation today, we will be sharing with you that presentation. And if you have questions for Dr. Rama or Dr. Prem, or you'd like to participate in some of the further studies or further presentations that show the readiness model and the tools that the gents have developed, please contact us via alumni@westernsydney.edu.au, our alumni email address. I wanted to thank Dr. Rama and Dr. Prem for their time, and also thank you to the Western Sydney University alumni team who have put together this session, and all of you participants who have joined us as well. I hope you have a great afternoon. Bye-bye.
Thank you very much. Bye-bye, everyone.